let's start. This time the theme will be very different. It will be very technical, and it will be about one very certain area of development of the game development. We will talk about CI/CD processes, continuous integration and continuous delivery process. And we talk about how AI infrastructure, how new technologies based on AI progress can help us to improve CI/CD for mobile game development. So let's start. But let's talk a little bit about Playrix because my experience and what I will describe later is based on what we have done in Playrix in developing, in changing the how development has been done and how CI/CD process has been organized in Playrix. Playrix is one of the leading mobile game developers in the Europe and maybe also in the world. We have a very large number of developers which develop our games, and our active DAO can be active MAU is up to 100 millions. So yes, we have rather popular games, and we have a lot of developers who help us to make these games the one of the best at the market. So what about inside of the Playrix? What happens inside? What happens in development? So we have more than 10 different games, different projects, uh, and we have more than 500 developers who works on these games. All of the games, almost all of the games are using our own C++ based game engine, both game engine itself and game logic using mostly C++, and it is up to 2 million lines of code for each of the game. So it's quite a large project. And we built the game for different target platforms, of course, including all mobile platforms like iOS or Android, but also for Windows and macOS. Not only for developers' purposes, because our developers develop the game and has them on these platforms, these top platforms, but also we have gamers, we have end users who use these desktop platforms to play our games. And we release a new version of our games, usually once per 6 weeks, but we sometimes have mid releases, in between releases, once per 3 weeks. So this is a little bit about Playrix and about what we are working on and why do we need some improvement in our CI/CD processes, and why do we need the help of AI to get all of this working better. Okay, but let's start from CI/CD with the general terms. So let's discuss about what do we want from CI/CD, what is a good CI/CD, and how it can be improved, and what are the areas of improvement that and where AI can help us. So if we talk about CI/CD, why do we need it? What do we need from CI/CD? From one side, we have the developers who create the new features. We have technical designers. We have artists. We have narrative designers. We have a lot of people who make some changes, who create some new interesting features in the game. And we would like to build this and make all these features possible to play with to our end users. And our end users mostly uses their mobile phones. So we need to get these changes and move through whole pipeline to deliver it to the mobile devices of our end users, of our gamers. And what also do we need during this pipeline? We would like to ensure the quality. We would like our game to be the fast and smooth as possible, and we would like to check and eliminate all of the bugs during this pipeline to be sure that our end users receives the best experience as possible. And also, we would like to automate these processes as much as possible, because if you try to do these things manually, it will require much more time and much more resources to do, to fulfill. Okay, this is what about the CI/CD overall? What is it, and why do we need this CI/CD process at all? Let's dive in mobile applications and game CI/CD. It has some differences and it has some additional problems, and maybe a little bit more complex, a little bit more harder than other types of CI/CD. Um, First of all, there is a very high cost of any issues that appears in production. Why? First of all, because we cannot just deploy our game to production and make it available to our users. In most of the cases, we need to go through review by store, like App Store if we deploy to iOS, or Google Play Store if we deploy to Android, and it can take from several hours or one day, or in worst cases, up to 1 week to go through this review. And even when we uh, pass this review, if everything goes wrong, we cannot just roll back to the previous version. What we can is just to apply new version and wait again for the review. And only when we pass this review, we can deploy and distribute the new version with the bug fix. So this makes the cost of any errors much, much higher than in any other types of deployment like front-end services or back-end services. Of course, there are some additional ways about how to make it a little bit easier, like live ops, like feature flags, etc. But there are a lot of cases where you cannot use it and you require to upload the new build. So we need to be sure that everything is as smooth and as good as possible on this way. The second problem with mobile CI/CD is that we have a lot of different platforms and a lot of different configuration that we need to check and that we need to build for. For example, if we talk about Android, it's not just one store, it's a lot of different stores. Google Play, Huawei App Gallery, Samsung Galaxy Store, Amazon, etc., etc., etc. So we have a lot of different configurations to check and to build with, and it makes everything much more complex and requires much more additional resources. Uh, the third problem is the speed of building. Uh, in our case, because of the size of our project and because of the C++ as a language, we if we use a clean build without any additional instruments, any additional tooling to make it faster, it can take up to several hours to build the app. Of course, we have a lot of additional tools to make it faster. We use batching compilation, we use distribution building, we use distributed caches. But even when we use as much additional tools as possible, we can decrease this time in average up down to half an hour. But usually it takes a lot of time. So we need to take it into account. Uh, Also, the problem is with the testing itself, because to test that everything is working correctly, you need the test that should be run on real devices. Because there are a lot of cases that requires a real device possibilities to perform the test. And of course, testing on real devices. In some of the cases, we can replace these devices with simulators or emulators. But in any case, we have a lot. It's not as fast as testing as unit testing or as integration testing. Even if you use simulators and emulators, it takes a lot of time. And if you require uh, real device testing, it requires much more time. So uh, I hope that you understand now, even if you do not have not experience with working on development of mobile games, that CI/CD in mobile games development is hard. So we need any help with any additional instruments as possible to make it easier and to make it faster. So how do we define that our CD is working well or needs some additional improvements? First of all, is the quality of the end product. We would like the end product, in our case, a mobile game, to be the best quality as possible without any functional problems, without any performance issues, without any freezes. So we need to check as much as possible during this pipeline. The second metrics will be the speed of pipeline. We will talk about this a little bit later, but usually we require a lot of additional loops during the development. So it's not just changing something and deploying it to our end users. It requires additional loops. Okay, that's almost okay, but we need some small changes and one more changes and one more changes. So the speed is very crucial to make as much loops as possible in a shorter period of time. And the third metric will be the cost because of number of builds, because of the time. We need a lot of build hours, we need a lot of resources, and it can cost a lot of money. And in our case, CI/CD is have quite a lot of cost, and we spend a lot of time in FinOps to improve it and to make it cost lesser. Okay, so this how can we define how can we decide whether our CI/CD is good enough or do we need some additional improvements? And let's talk about additional problems. Why it's not perfect? Why do we have the problems with the quality, problems with the speed, and problems with the cost? And one of the main problem is humans. Because in these CI/CD pipelines, we need human in the loop. We have a lot of points that requires direct attention of developers or some other engineers. And why human is a problem? Why human in the loop is a problem? Human in the loop um, gives us the problems in all of these metrics, can decrease all of these metrics. In terms of quality, errare humanum est. Developers can make mistakes. Any human can make mistakes. So if human make some decisions during the CI/CD process, it can make sometimes wrong decision. In terms of speed, usually engineers are the slowest part of the system. And also the problem is with asynchronous async type of interacting with humans. So we can ask engineer to make some changes, but we cannot be sure that it will implement it right now or implement it in next hour because he can have some other issues. Can be absent from the work. So there can be a lot of reasons why he will not do it right now or in the closest time frame. And also the cost. Human is rather uh, not the cheapest part of our system. Engineers' times cost money. He can spend it on creating some new features that will bring us new users and additional revenue, or he can spend it on fixing some problems in CI/CD, which is required, but maybe will not get us additional users and additional revenue. So what can we do with the human in the loop? Of course, the best way will be to remove the engineers, remove the human from this pipeline at all, and to automate it as much as possible. Some companies in some areas almost maybe mostly achieve this, but there are a lot of cases where it can be achieved. So when we cannot achieve it, so when we cannot replace the engineers as a whole, we can, what can we do? We can amplify the engineers. We can, by increasing their productivity, we can make the overall pipeline work better and work faster and cost us less money. So we try to do the both. We try to replace engineers in places where we do not need them, where we can work without them, and where we cannot do without them, cannot work without them. We try to increase their productivity. So let's talk a little bit again about the productivity, because if you want to increase the developer productivity, we need to understand how can we affect it. What are the areas that we should focus on if we're talking about increasing the developer productivity? Uh, one of the scheme about how to work with the developer productivity, the most favorite, my favorite one, is the feedback loops, cognitive load, and flow state. Feedback loops is these loops where developers receive some additional feedback, which requires him for do some additional changes. For example, builds failed at the pull request, some tests failed at the pull request, and he need to make the fixes to pass this test. This is a feedback loop. He received some bug report from the QA. This is a feedback loop. The producer asks to improve some animation. This is a feedback loops. So all of this, everything, almost everything that developers works with after it creates the change itself is the additional feedback loops about what should be changed later. The cognitive load, this is about how much efforts requires from developer to implement these changes that required from him. And the flow state is about are the developers in the state of the optimal performance or not? Why he not always in the state of optimal performance? We will discuss in the next slides. Maybe it has been a little bit complex framework from the first point of view. So let's try to use a simpler analogy to understand what all of these areas are about. So let's, for example, imagine the situation that we need to get a lot of different packages from point A to point B by some van or some truck. So feedback loops is our roads. We can have straight roads from A to B, or we have a lot of complex roads with a lot of detours. Of course, the straight and simpler roads are better. And also, if we cannot get all the packages in one drive from A to B, we need to have a lot of additional drives. And of course, the lesser number of these drives will better is better than the more number of the greater number of these additional drives to getting additional packages. The cognitive load is like a quality of the road. If the quality of the road is good, we can drive at the more faster speed. If it's bad, we cannot get the best speed, and we need to move slowly. And of course, it will get us more time to get the packages from A to B. And the flow state is about some additional problems during this driving. If there are a lot of traffic lights, if there are a lot of traffic jams, of course, it will take a lot of additional time. It will also decrease the overall performance, the overall productivity of our delivery. So I hope that this simpler analogy will help you to understand better these areas of developer productivity. So let's try to use this framework for human in the loop in our CI/CD. How it's how this framework is work with CI/CD processes. Is implemented in CI/CD processes. Feedback loop is, as we have described previously, is our additional checks that can be passed or failed. And if this check has been failed, it requires developer to make additional changes during this to get passed through this check. So one of the most so in different companies, the number of these checks can differ a little bit, but I think most of the companies has the checks like code review. So you need to get through code review by some other developers to get into the main branches. The additional checks on the pull request level before merging your changes to the main branches. In some companies, there are additional requirement for some regular builds, for example, nightly builds, etc., etc., etc. So this is feedback loops in our CI/CD pipeline. What about cognitive load in CI/CD? When some check fails, the developer, the engineer, requires to understand why has it failed and what he needs to do to fix it. So if if it's complex, if he needs additional time to understand what happens and why the error appears, why the test has been failed, it will be harder for them. So the cognitive load is about to understand why the check hasn't been passed and what he needs to be able to pass it. This is the cognitive load in CI/CD. And what about flow state? Why the developer is not always at the optimal performance state? According to different researchers, people, engineers, any type of professions that requires creativity cannot just switch from one task to another. Switching from task to task breaks their productivity and requires additional time to return to the optimal productivity. And even if you do not switch the whole task, but have some interruptions during this task, it's also the same process. If you have been interrupted during your work, you need additional time to get to this optimal state. And research shows that in most of the cases, it requires up to from 15 minutes up to 30 minutes to return to the optimal state. And our CI/CD, if it requires human attention, engineer's attention, it creates such an interruption. Developer works on something new, working on the next tasks, but the checks during the CI/CD creates interruption, says, wow, you cannot go further. You need to return to your previous task because the test has been failed, because the reviewer asked for some additional changes. It is an interruption. Engineer requires to switch his attention. It breaks his flow state, and it requires additional time to get into the state of optimal performance. So, how can we improve the whole process, and where are the areas where AI can help us with? So, we described the areas that has been can be affected. That can be on what areas should we work to improve the developer productivities. So AI can help us to speed up feedback loops to make them faster and shorter. AI can help us to decrease cognitive load, and if it will be able to minimize the number of interruptions, the whole process will work better and the developer productivity will also be better. For the scope of this presentation, I will minimize the number of feedback loops which we will talk about, because we will not be able to talk about every of them. But let's focus on so-called maybe classic CI/CD. Let's talk about code review, about checks on the pull request level, and about regular checks like nightly builds. So first of all, let's talk about how AI can help us with the code review. Uh, there are a lot of solutions at the market. It's one of the hottest theme right now in working with AI to improve the developer productivities. So maybe we are at the state where we can fully remove the human from the code review and replace it with AI. Let's discuss it. From my point of view, we are close enough to this point, but currently we are not at this point. Maybe at some companies and at some projects, it can be already achieved. But if we talk about the game development, about the mobile game development, about large game projects, from my point of view, it is not achievable right now. And let's discuss why. So if we talk about issues of medium complexity or easy complexity, yes, current LLMs can easily detect them and suggest the right way about how to fix it. And we have seen it on our pull requests and in our projects. If we talk about harder problems and more complex problems, this is not ready yet in our experience. For example, we have some cases where AI suggested using different C++ containers that we have used right now, and said that it's high priority. You should replace this container because you're using the wrong container. But the problem is that, yes, in the general situation, what AI has been suggested is the best approach. But in our case, because of how we will use this container in runtime, how we will read it, how we will write it, how we will replace elements in it, the advice of AI will be very, very bad decision and will decrease the performance. Why I suggested it? Because it has an additional context about how we will use it later in runtime. But engineers, the experienced engineers, the engineers that works on this project can have such a context. So for some hard and complex issues, AI may be not the best solution right now. Maybe in the next years it will be able to work with these complex issues too, but right now it's not ready yet. Also, code review is a very good way to transfer knowledge from one engineer to another, from maybe more experienced engineers in the project to engineers with less experience in the project. If we fully remove engineers and people from the code review, we will break this process. We will not be able to use code review to transfer the knowledge. Maybe we will be able to create some additional ways of sharing this knowledge, but currently, if we just replace, we will break this process, and it is not very good in terms of adoption of engineers and to creating the overall culture on the project, overall developing culture of the projects. And also, it can give the problems with co-ownership and buzz factor. Because if nobody except the developer itself who creates the changes and the AI understands what and why has been changed and introduced, the new developers, the other developers will require a lot of additional time, a lot of additional cognitive load, cognitive efforts to understand if what happens there, if it will require to make some additional changes. So if we remove the people at all the wall from the code review, we can also broke this ownership and we create the bus factors in some part of our system. So this is the point why we haven't replaced the engineers from the code review uh, wall, but we can help them to make it faster and to make it better and to require lesser efforts from the developers. How can we help AI? What AI need to make the code review properly, to make it the best as possible? First of all, it needs to understand what's going on in our projects, how we are working with our code, what are the rules, what are the good way of doing things, and what are the bad way of doing things. The second one, it needs additional info about the task, about what the developers want to achieve, about some additional restrictions and constraints in our project. Uh, and also, we need some iterative process to be able to gradually improve the quality because uh, to understand what should be, does we have enough context, does we have enough rules, does we have the right prompts, we need to have the feedback to be able to incorporate the feedback from engineers about whether AI have succeeded in finding the issues or it have failed. And if we have such information, we can interact, we can gradually, incrementally change these prompts, change this additional context management, and improves. If we have not such a feedback, we will not be able to improve. So this is what we need from the good system, the ability to manage all of these things. We need them to improve the quality of the AI code review. So usually all the companies have to choose between two ways, whether to buy some SaaS solution which are already at the market or to create their own custom solution and to fine tune it to their own needs. Of course, SaaS solution is much easier in integrating, in adopting, and into setup. But and now there are a lot of different companies that provide such SaaS solution, from Copilot and Cursor Backbot to Codo, Code and etc. 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 And even OpenAI. Uh, but sometimes you have these types of the system have not enough points of customizability and of improving. And for example, in our case, we have not been able to get the quality of code reviews that we would like to have using all of the system. We have the benchmarks, we have some internal benchmark based on the pull requests that we have, and they showed us that the quality is not good enough because we cannot provide additional context. We have not additional customizability in terms of rules, so we have implemented our own solution. So let's describe what do you need and how can you create such a solution. You need some runner. So this is where this check will be run. For example, you can take GitHub Actions as a runner. You need some tools that can interact with the LLM. For example, you can use any command line interface tooling like Gemini, Codex, like a Cursor agent, or for our example, we have used the Cloud Code. You need to monitor the user feedback. So you need the mechanism to collect the user feedback about whether code review goes right or wrong. Uh, we have collected all this information and gather them in our metric system. In our case, it's amplitude. And also, of course, you need additional monitoring about how AI has been worked to be able to control the cost and control the time and control some situation where everything goes wrong. For example, Sentry has a rather good instrument where you can collect all the data regarding the working of AI agent. So this is one of the example of how this architecture of custom code review solution can looks like, and this is how we have organized it and implemented in our company. A little bit about tips and tricks. Use as much sub-agents as possible. This help you to decompose the more complex tasks on more simpler tasks. For example, you can use sub-agent for security analysis, for functional analysis, for performance analysis. Each of them will have their own context, so it will help you with the problem of large and unfocused context. So each of them will have their own focused context. There are a lot of different command line tools that you can use for the code review. For our case, the Claude Code with the Claude 4.5 Sonnet is our favorite choice, but we can easily experiment with other one. And also to make the adoption as easier as possible, use a dry run to understand how it works, compare it with your benchmarks, and then you can, after you receive the good results on the dry run, you can incrementally adopt it on the wall level and introduce it to the user. Okay, let's go next. The next part will be the checks on the pull request levels, the pull request builds. Why it is a problem in our case? As we have described previously, the CI/CD for mobile development requires a lot of different builds because we deploy our application to different target platforms, and also because of C++ and because of a lot of additional assets, it requires a lot of time to run these checks. So how can AI can help us with these complex and large builds? So first of all, why the long builds are bad? Of course, it costs us more time and more money to run through these complex builds and to understand through a lot of build logs what's happened and what have failed. So how can we introduce AI to this system? When we have some failed builds, usually we have an agent where it happens. And our way about how to improve this process is to introduce AI CLI tool directly to this agent. So we do not run some additional checks, some additional agent. This agent is run directly on the same agent that has built and that has some failed logs. Why it's important? Because we can incrementally rebuild this build to test any fixes. In our case, the incremental build, if you have everything already built, takes just several minutes. You can compare it with half an hour or maybe up to 1 hour and more if we talk about the new build on the new agent. And this agent, you can make it just in several minutes. And it allows us to make some iterations and try to fix it. And if we have been able to find the patch that have help us to pass through the compilation problem, through test problem, you can just introduce this change to the user. So this can help us a lot to not require the human to get into the system to understand from build logs what has been happened and why it fails, to understand what has been changed. We can just do it by AI and just introduce the change to the user, to the engineer, and said something has been failed. we suggest that this is the problem that has been arised, and this is the fix that we suggested. Press apply to fix everything. Uh, of course, it's not so easy to implement, so I have additional tips and tricks for you. And first of all, if you will not be able to achieve it in a small number of iterations, usually the problems is more complex and maybe not achievable by AI. So we constrain it only by 3 iterations to try to fix the builds. If we haven't been able to do it in three twice, it means that it requires human attention because something is too complex for our AI instrument. Okay, the regular builds. What is different? Why have um, check everything at the pull request level? Again, because of the number of the target platforms, the complexity of the checks, the time of the build leads us, makes us not, we haven't been able to run all of them on the pull request level. It will, if we try to do it, it will require several hours for each pull request and a lot of additional resources. So we have to decide it and to move some checks from the pull request level to the regular level, for example, nightly builds level. Okay, so what are the main problems with regular builds? You have a lot of pull requests during the day. In our cases, it can be 100 pull requests per day for each of the projects or more. If something fails during the day, you have just the result at the end of the day that you have a lot of changes, up to 100 pull requests, and something does not work. And to understand what have not worked and why it have, and what exact pull request has broken the whole check, it's very hard to understand and to get. We use a bisect. Bisect is a binary search where we divide everything by 2 halves, understand whether the middle of our search is green, so pass the check, or red, so doesn't pass the check, and decide whether we go right or left in terms of timeline. So bisect can drastically decrease the time of finding such a build, the pull requests that have broken the wall check. And if we talk about 100 pull requests per day, for bisect, we need only 7 checks. Compare it with trying to check everything. It gives us speed up to 14 times. So how we use it in our CI/CD? We use bisect to find the exact pull request that have broke the check, and then use the same AI system that we have discussed previously to try to fix it. The same system, because of the incremental ability to incrementally run the build on the agent, it can take just several minutes for each try to fix. And one more, what additionally can be achieved by using the AI fixes during the bisect and during the regular builds, it can help us, and this is the single way about how to do it, to find the multiple issues. So if during the day there has been the several pull requests that has broke your check, it is very hard to find all of them, because in some of the point you have several problems that has been that has broke the build. But if you have the ability to fix and to create the patch, you can apply it and use bisect one more with this patch to find the next issue. Then create the new patch, create the cumulative patch, and run again. And this will allow us to create to find the multiple issues and to fix them and to create the cumulative patch, even if there has been several issues during the day. It's a very, very important and can save us a lot of additional money and time. Also, you can apply the same idea to the working with the test. But with the test, there are additional problem, the flakiness. Usually, if we talk about the test on devices, working with the end-to-end test, both on simulators, and devices, if they are flaky, if they can pass or fail with some possibility, it will break all the bisect problem. Because if you fail on some point, and this is not because of a real problem, but because of the flakiness, it will break the bisect. Of course, there are some ways about how you can overcome it. For example, you can rerun, you can measure the flakiness, you can ignore the flakiness test, but it is the problem. It is additional problem. So working with a test is more complex uh, for bisect and for fixing the regular builds. And what we are doing now, we are uh, improving the ICD using the techniques that I have described before. And also we are trying now to use these building blocks to create more standalone pipelines where user just started and then everything goes automatically through these pipelines. But this is the future, and I will talk. I hope that I will be able to talk about it a little bit later, maybe on the next game dev conference. So that's all for now. Thank you very much for attention, and I will be happy to answer your questions if you have one.
Hi, Ilya. Thank you very much for a very interesting talk there. That's quite a system you've got set up there to help you with your builds. Do you find that basically, is it helping? Is it working?
Yep, yeah. We are not fully implemented and fully adopted all of these parts, but the results that we have achieved during the both code review and uh, creating the after patches are very, very interesting for us, and we continue the adoption and continue the improvement. Also, as I have described before, this is one of the very important points of this whole process, to be able to incrementally improve. If you create the systems that can be incrementally improved, you will not be able to achieve the good quality. One of our main approach is to create the system that can be achieved, that can be improved. So we get, each time we gather the feedback from our users, from our engineers, and use this feedback to improve it a little bit, a little bit, a little bit, a little bit. And what we see that we can improve. So maybe the quality right now is not what we would like to have. We would like to have much better quality, but we see that we able to incrementally increase it. And this is the main point, because if we can create the trend and we can reach this point of the quality that we needed.
I was actually going to ask about feedback and how you take that feedback and use it, because you did mention you'd want the AI to sort of learn and understand and extend its context. So when you say you collect feedback and sort of iterate on that, what do you do with that feedback?
Yeah,
How do you do that?
the simplest example is about code review. So what signal can we get from the pull request? First of all, we introduce reactions. So each developer can just use thumbs up, thumbs down, or confused emoji just to express his reaction to what the AI suggested. So this is one type of the feedback that we can gather. Of course, usually developers is a little bit lazy and they do not want to use the reactions. We ask them, but of course we collect some feedback, but of course not at all. And the second important signal is how much issues that has been displayed by the AI code review has been fixed. Because if it's important, if it's really important, the user will fix it, and we will be able to check that it disappears from the pull request before the merge, when they merge it. But if it does not, it hasn't been checked, it hasn't been fixed. This is a very, very uh, powerful signal that it's not important, because if we showed it and developers decide to do nothing with it, it's not important. So we can use this signal too, and use it to improve our system. And then, of course, we have examples where we have been good and where we have been bad, and we can try to incrementally change and see what to understand what are the common problem in the situation that has been disliked by users, and try to fix it by using additional context or using additional rules, additional knowledge about this. So the problem can be that there is no enough knowledge for the system, enough rules for the system, or it has no enough context. So because we have customizable solution, our own solution, we can provide the both.
Right, yeah. So I was curious then as to whether it was sort of adding extra rules, adding extra context, and then kind of the next iteration would then hopefully have more information to be able to work with it.
Yep.
Yeah.
Yeah.
I guess then when the AI does fix something, which is hopefully the goal, what do you do with that build then? Do you automatically check it in? Do you kind of have to have human in the loop again to verify it and accept it?
Currently, at the current state, we try to verify it additionally with human, because
Mm,
it's adoption state and we are not sure enough to be able to
mm,
just push it to the branch. But I hope that in the future we will be able to do it automatically. There is a very interesting research paper from Meta engineers. They have used their own system. Of course, they created their own system for AI code review, and they compare that the best way to introduce such changes will be to show them only to author of the pull request. Because if you show them to the reviewers, like to additional human reviewers, it will require for them to additional times to recheck it. And usually it's not improve the time of the pull request review, but decrease. Oh, not decrease, but increase the time.
yeah.
So they find that the best configuration will be to show it directly to the author, and he will decide just to apply it or not apply it.
Yeah, that kind of makes sense, I guess. Alex, sorry.
But will it be biased by the author of the PR and the changes provided by the AI? Like, we are not only talking about the speed of the review, but on the quality as well.
Of course, he will be biased. Yeah, you need to work with it. So
Got it.
this is one of the problems with all the AI. If the human who worked with it does not trust it, it cannot work. The system will not work because he needs to trust it. So we need to educate. We need to help them understand how it works. We need to show them the results. That it's really helpful. So only through this additional approaches. So we need to spend a lot of resources and time to do it, because yes, of course, the biasing is a problem.
Mhm. Yeah, I think trust is very important in this kind of a loop of the feedback. Last question, I think, to finish things off there. You were talking about tests and everything. Do you find that tests are very important for this kind of a process?
Evals are very important.
Okay.
Evals means the benchmarks for everything that you have implemented.
But you were also
Uh,
mentioning end-to-end testing for your actual builds.
Uh, yeah, if you talk about end-to-end testing, yes, and end-to-end testing is a very important part of our pipeline,
Mm,
because we cannot just check everything on the unit test level or integration test level. We need to see how it's work from the end to end, from the overall pipeline.
yeah.
So yes, and this is in many cases the most complex problem
Mm,
with AI or without AI. They has flakiness. They requires much more time than any other types of the test. They are very hard to understand why it has been broken, because if you have a compilation error, you can just see in most cases, you can see, okay, yeah, I have a compilation error on this line and I need to fix it. But end to end, everything just not working. The
yeah.
application just not started. Why? Or the animation does not play it. Why? Nobody knows. So for end-to-end tests, it's very, very important to find the exact changes, to find the exact pull request that has broken it. because when you just have 100 pull request changes during the day and something does not work at the end-to-end level, it's very hard to debug this kind of problem. But if you can minimize, if you can using BSEC, if you can find the exact pull request, it's much easier both for the human and both for the AI, because if you introduce to the AI the result and the simpler problem, it can be much easier for it to use the same iterations to try to fix it. Okay, try to understand what's happened, try to make the fixes, rerun the single test that has been broken, and to see what is the result. If the flakiness will be low enough, it will work. But one of the main problems with all mobile end-to-end testing is the flakiness.
Well, yeah, game development isn't known for its rigorous automated testing, is it?
Yeah.
Yeah. I'm going to leave it there before I insult anybody else with the testing comments. But thank you very much. It's a very interesting topic. It'd be really interesting to know how this evolves over time, and hopefully it'll provide great value to your builds and to your engineers.
You're welcome. You're welcome. Thank you, everybody, for the attention and
Thank you
for
very
the
much.
questions.